All right, now we're ready to do examples 2, 3, and 4. And in those examples, I'm going to teach you how to use SOHCAHTOA to find a missing side. So continuing on page 67 in your ISM, for example 2, I want you to draw this triangle. And instead of using theta this time, we're actually going to know the angle measure. So in this angle right here, I want you to write 35 degrees. Okay, for this picture, when you see a picture like this and your instructions are to solve for x, you first have to figure out whether you're going to use sine, cosine, or tangent. So when I'm looking at this angle, everything is based on where this angle is. What is my x in relation to this angle? Is my x opposite, adjacent, or hypotenuse? Well, since it's across from the right angle, my x is the hypotenuse. What's the 14 in relation to 35? Well, since 14 is touching that angle, it's next to it. That's my a. So I'm going to do a and h, which is cosine. This is your ka. So I'm going to have cosine of, and instead of putting theta like we did up here, we actually know the angle, so we're going to put in 35. Cosine of 35 equals adjacent over hypotenuse, because it's ka, so the a goes first. So 14 over x. Okay, so this is my equation. And now we can use our calculator to solve this equation and help us find x. So you need to get a real calculator, not your phone. So go hit pause and go get one from the wall, or if you don't have your own. All right, on your calculator, your calculator comes in different modes. If you have a calculator from the wall, if you'll hit this button right here that says mode, turn it on. You'll hit this button that says mode. See right there it says radian and degrees. You want to make sure your calculator is in degrees. If it is in radians, you will get an answer, but it will be the wrong one. So make sure your calculator is set in degrees. You'll learn about radians later on in another class. If you have a different calculator other than this one, you should still have a mode button. You might have 3 modes, radian, degree, and gradient. Just make sure that your calculator is set in degrees. Okay? Just hit clear to get out of the screen. And now that you're in degrees, we're going to type in the cosine of 35. So right here, you're going to hit your cosine button and see how your parentheses come up. Then you're going to type in 35, enter. That decimal is the value of cosine of 35. To make our answers be as exact as possible, we're not going to copy all of those decimals, but I do want you to copy 4 of them. So we're going to put 0.819, and since after this one is a 5, we're going to round that 1 up to 2. So 0.8192. Just always use 4 decimal places when you're dealing with trig functions. Equals 14 over x. Okay? All right, so now we need to solve for x. Well, since x is on the bottom of the fraction, and you don't need to write this part, just listen to what I'm talking about. Since x is on the bottom, if I want to get x out from the bottom, I would multiply this side by x, and that would cancel those out, right? And then what I did to this side, I would do to this side. So I'd multiply that side by x. Well, if I did this, you would end up with 0.8192 times x equals 14. And then to solve for that, you would divide by the 0.8192. So what we're going to end up doing is taking this 14 and dividing it by this decimal. So instead of doing the algebra work of multiplying by x on both sides, we're just going to understand that that's what's happening, and we're just going to do the math with our calculator. So when you have a number on top, this number stays on top, which means it goes in the calculator first, and you divide it by your decimal. So on your calculator, you're going to type in 14 divided by 0.8192, and you get 17.1. Now for your answer, you can use 1 or 2 decimal places. I don't really care which one you do. I normally use 1 decimal place. But that's your answer. X is 17.1. So the trig functions allow us, if we know the angle and we know one side, then we're able to figure out what x is, because we couldn't use Pythagorean theorem for this because we don't know this other side. Well, trig functions give us a shortcut that the hypotenuse of this triangle is 17.1. Okay? Now let's do example 3. All right, we're going to let this angle down here be 55 degrees. This is 16 and this is x. So first we need to figure out if we're using sine, cosine, or tangent. So look at your 55. You have to go all the way across the triangle to get your x, so that's your O, that's opposite. Your 16s are crossing the right angle, so that's your hypotenuse. And so you've got O and H. O and H is SO, which is sine. So we're going to do sine of the angle, so sine of 55 equals opposite x over hypotenuse 16. Okay? Now grab your calculator, hit the sine button this time, and type in your angle, 55, and you get 0.8192 again. Now, there is a reason that cosine of 35 is 0.8192 and sine of 55 is 0.8192. I'm not ready to tell you that reason yet, but there is a reason these two numbers match. It will not always match. So you're not going to get 0.8192 for every single problem. It's just because of something that's true about these two equations, and I'll tell you about that in a later video. Okay, so you get 0.8192 equals x over 16. Now this time, do you see how my 16 is on the bottom? Up here, 14 was on the top, and we had to do 14 divided by that. Now that our number's on the bottom, what are we going to do with these two numbers to solve for x? You're going to multiply them. So you take your calculator and you do 16 times 0.8192, and you get 13.1, and that's your x. So x is 13.1, which is this side right here. Okay? All right, what I want you to do now is I'm going to give you example 4, and I want you to try it, hit pause on the video, and try it, and then come back and I'll work it out with you. So here's example 4. Put 61 degrees up here at the top. And then this is x, and that's 7. That's a 61. It's a little small, but that's 61. Okay, I'm going to hit pause for a minute, and you guys see if you can figure out what x is by yourself. All right, if you tried this problem, then your 61's right here. See how x is right next to the 61, but it's not the hypotenuse? That means x is adjacent. The 7, you have to go all the way across the triangle from the 61 to get to the 7, so that makes it O, opposite. So O and A, that's TOA, which is tangent. So tangent of 61 equals opposite 7 over adjacent x. Okay, grab your calculator. Tangent of 61 is 1.8040. Okay, equals 7 over x. And again, see how your 7's on top? Are you going to multiply or divide? You should divide. So you do 7 divided by, make sure you put this number in first. So 7 divided by 1.8040. And for your x, you get 3.9. Okay? So hopefully you did that problem correctly. There is example 5 that we'll do in the next video, but right now you need to look back at your table of contents and find out which problems you need to do on the next worksheet in your packet.